Okay, guys, this is the last lesson you have to get through, and then a quiz, a test, and a final, and you have your credit, which is really exciting. So we're talking about volume of spheres. When you hear a sphere, you should just think like a ball, essentially, an orange, the set of all points equidistant from a given point. But really, it's basically kind of like a circle, but three-dimensional, where you can take this radius length, you could draw it there, or you could draw it there, or you could draw it here. It doesn't really matter where you draw this. All the points that are this distance away will make up the sphere. So that's what a sphere technically is. So the radius, as always, is the distance from the center to the end. Here, the center is the center of the sphere and has its endpoint somewhere on the edge of the sphere. But if you go through the center and have your endpoints on the sphere, you're talking about the whole diameter at that point. So in this picture, this segment would be a diameter because it goes to the center, but each end is on the sphere. Whereas this guy starts at the center. Now, the formula for the volume of a sphere is weird, and I have no idea where it comes from, but it's 4/3 times pi times the radius to the third power, which, remember, this means r times r times r. You're taking that radius length times itself 3 times. So that's what we're going to use for this first sphere. We're going to take 4/3 times pi times r cubed. So I need to substitute in r. That is the nice thing about this formula. There's just one thing to plug in. So I need to know the distance from center to edge, which I don't currently know. 18 is the diameter because it goes all the way across. I don't want that. I want to start at the center and then go across. So I want half of what they gave to me. So if this is the diameter, then the radius is half of 18. That's what I'm going to plug in here to the third power. Just like we did with cylinders and we did with cones, one of the versions I'm going to ask for the answer is in terms of pi, which means temporarily I will not use pi in any capacity. I'm going to ignore it. I'm going to do 4/3 9 to the third power. Now, if you happen to be lucky enough to have an actual calculator with you, which I have here, you could just, not do that. You could actually do the 4/3 on this. So I'm going to push 4 divided by 3 for my 4/3. I'm trying to get some decent light so you can actually see what I'm typing in. 4/3 times 9. Now I could just do times 9 times 9 times 9 because it's to the third power, but the caret button above my divide button is telling me to do it to the third power. And again, that's the same thing as 4 divided by 3 times 9 times 9 times 9. So you get the exact same answer. And if you happen to know how to do fractions on your particular calculator, knock yourself out with that. Unless you're like me and then you do it wrong. I need to actually look at my screen when I type things. Either way, you can do it that way. However, I know a bunch of us are using our phone calculator. So as always, make sure you have your rotation lock off. And when you open this up, turn it sideways. Now, I'm going to recommend you do this in chunks. So the first chunk I'm going to recommend is 9 to the third. So 9, I see x to the third. You can't see where I'm pointing. X to the third right there. And then I want 4/3. So the way I'm going to recommend you do that is times 4 for the top part divided by 3 for the bottom part. So again, I did the 9 to the third, 9 times 9 times 9. You could do that, or you could just do 9 to the third, and then times 4 for the top, divided by 3 for the bottom of that fraction. So we're all getting 972 no matter think when I made the answer key, I did it in smaller chunks even. So I kind of wrote out what I just said. So I wrote out that 9 to the third was 729. I actually think I might have done the divide by 3 first. No, I did multiply by 4 first. So I'm just going to say, whoa. Why is that there? So the next thing I did was I multiplied by 4. So 729 times 4. My calculator said 2,916. And then I divided that by 3, which gave me the 972. And again, you'll notice this whole time, I have not done anything with the pi. It still exists. The volume in terms of pi is 972 pi. But then when I do it to the nearest whole number, that's when I hit times the pi button on my calculator. And I'm getting 3,050, technically 4, because it was, my calculator said 353.6, so this 6 makes the 3 round up. So you don't have to necessarily write all of this jazz down, but especially if you're not working with an actual calculator and you're trying to use your phone, I do recommend it. Let's do one more. Number 2, another sphere, 4/3 times pi times r cubed. So I need to know what my radius is. Luckily, they're giving me the distance from center to edge, so I don't need to do anything with that. I'm just going to plug it in. That's the number we're going to take times itself 3 times. So first thing I'm going to do is just figure out what is 10.8 to the third power. So when I put in 10.8 to the third in my calculator, it spits out 1259.712. Then I'm going to multiply by the 4. So I'm going to leave everything else alone. I'm going to figure out what these two numbers multiplied together are. So times 4. I'm getting 5,038.848. That's what I'm going to divide by 3. 6, 7. Oh, sorry, I forgot I write the pi first. So I'm just going to keep dropping that pi down. This divided by 3 turns out to be 1679.616. And I'm just going to leave a decimal with my pi. I think if I remember correctly when I was looking at some of the answer keys to the upcoming quiz and test on this unit, I think when you get an answer that's a decimal like that, the answer key just kind of rounds it. So it would say it's about 1680 pi. So it's not exact, but I'd rather have a whole number in front of that pi. So when I multiply that by pi, I'm getting 5277 approximately. Oops, let me try that again. Double check my work. Yeah. So we got our 2 volumes. Like I said, pretty straightforward because you just need a radius to plug in. It can get messy when evaluating depending on your calculator. And we're going to be rotating things, so